Jai Hind everyone. I am Shruti Jain, Assistant Professor, MCA Department, Ajay Kumar Garg Engineering College, Ghaziabad. The topic that I am going to discuss today is the topology in networks, and the subject code is BMC 101. It is for MCA students under the subject Fundamentals of Computers and Emerging Technologies. So what is a topology? A topology defines how a network nodes are connected with each other. Now, these nodes could be in terms of the electronic systems, the computers. It could be in the form of any of the router or the device or the server, or it could be anything that is used to transmit the data. The network is defined by the physical and the logical topology. So, if we talk about what a physical topology is, it defines how the nodes of the network are physically connected with each other. The logical topology, it is dedicated to the connections between certain selected source and the destination pairs. But again, when we are talking about the source and the destination, the underlying topology is again the physical topology. So to have an efficient system, the logical topology should be chosen such that the routing should be simple. But when the basic communication happens, that happens using the physical topology. So the different type of topologies that we are going to discuss today are the bus topology, the tree topology, star topology, ring topology, and the hybrid topology. So coming to the bus topology is a topology where we have all the systems are connected through a bus. The data transmission takes place on a bus, and these systems are all connected so that the communication, whatever data is transmitted from one place to another on a bus, is accessed by all the systems that are connected to a bus. So the advantage, this topology is useful in local area networks. They do not rely on the central host, and this network still functions if one of the computer malfunctions. So here, if suppose the C1 system malfunctions, then in that case also the rest of the systems will not be affected and the data transmission will happen in a normal way. The other advantage is it is easy to wire because it is being established in a very small area. It gives a quick response and it is less expensive. The problems that arise are the bad connection to a cable can bring down the entire network, and the collision may occur when two nodes are sending the data simultaneously. For example, both C1 and C2 systems are sending the data all together. Then in that case, the collision may happen at this place because both the systems are sending the data, and hence the collision may take place. So coming to what a bus topology is, all the stations are attached to a single cable. When a station sends a message, it broadcasts down on the cable in both the directions. The terminators at the end of the cable prevent the signals from reflecting to the senders. All the stations on the cables constantly monitor for the message meant to them. When a station detects a message meant for it, it reads a message from the cable and other stations will ignore it. Like we have, everyone has their own addresses and they just pick out all those messages which are only meant for them. And since all the stations share the same cable, some form of a control is needed to make sure which station will transmit when, otherwise there will be collision, as we have seen in the disadvantage of the bus network. The other type of network that we have is a tree network, where we have a node which has different branches for different systems. Like if we talk about this hub, now this hub has different branches which are connected to different hubs, and each and every hub is again either connected to a system or a hub. So here the area coverage is larger as compared to the bus network or the bus topology. So in a hub or a tree network, the wires that are used to connect different nodes are collapsed together into a central unit that is known as the hub. It does not perform the switching functions, but it consists of the repeaters that transmit all the signals from nodes to all other nodes in the same way. The multi-point nature of the tree topology, it gives rise to several problems. So the problems are the connecting wires, cables or the optical fibers, they form a closed loop and the data are passed along a ring from one computer to another, as we have seen here that the data is to be transmitted from one system to another system. But the use is, this topology is again useful in large local area network, and it does not rely on the central host. And it also still functions if one of the system malfunctions. If we look over here, if suppose this system stops working, it will not affect any of these systems that are connected into the tree network. The next type of a network that we have is a ring network or a ring topology. This is the diagram that we are going to discuss in the ring topology, where all the systems are connected to one another in the form of a ring. This is a unidirectional or a single ring where all the devices on a network share on a single cable. And this is the dual ring where the data is sent in both the directions, one in the clockwise and another one in the anti-clockwise direction. But when we are talking about a single ring, the data transmission is either in the clockwise direction or it could be in the anti-clockwise direction at a moment. So coming back to what a ring topology is, a ring network consists of the nodes that are joined by point-to-point connection to form a ring. Each node is connected to two nearest nodes so that the entire network forms a circle. And one method for passing the data onto the ring network is token passing, where we have different active topologies where each workstation transmits the data. The transmitted signal is regenerated at each node, because if we look over here, we have this is sending the data to this, the signal is sent to this device. Now again this device would be regenerating the signal so that it could be transmitted to another device. It is a shared access network and it has a capability of broadcasting the messages. It needs some form of access control to determine which node will transmit when. So the structure of this network is simple and it is very easy to insert and delete any number of nodes, and it is easily scalable and highly modular in nature. You can easily insert or delete any of the node that you want. Node here could be a system. Fault isolation and recovery are much simpler than the tree structure. The advantages, the most important advantage is it is a point-to-point connection, so the data can be transmitted easily. The electronic and the maintenance of point-to-point links are much simpler than the multitask links. The disadvantage is it offers only two alternate routes and thereby it can be managed only a single fault. Another important drawback of ring network is it is large in diameter, and if the diameter of the network is high, the number of edges that are involved in each communication will also be very high, resulting in high signal attenuation and the network blocking probability. The next one that we have is a star network topology, which we normally see in the client server, where we have the host CPU and all the systems are connected to these CPUs. To this CPU, and the data is transmitted from the host CPU to all other systems. So this topology is useful for the applications where the processing must be centralized and some can be performed locally. All the communications that pass through the central network, like all the problem over here is that whatever the communication needs to be done, that communication will be done through the host CPU. You cannot these two systems cannot communicate with each other. This is not possible. And the communication in the network will stop if the host system stops functioning. So if we talk about the star network, here each station is connected via a point-to-point link to a central point. This central point is called a hub, multi-port repeater or a concentrator. So here if we talk about this host CPU, here we can have a hub or any of the repeater which is connected to some other topology and is again repeating the signal so that those signals can be transmitted to all those devices which are connected to this topology. The central point may be passive, active or intelligent. So we have three types of hubs over here. If we talk about the passive hub, it simply connects the arms of a star topology. No signal regeneration is performed. It is just establishing the connection between different systems on the star topology. Now when that signal regeneration starts taking place, that becomes an active hub. So an active hub is like a passive hub, except that it regenerates the signals. Then comes the intelligent hubs, which not only regenerates the signals, but it also performs the activities such as selecting the intelligent path and then managing the network. So when we have the only the connection that is being established, that becomes a passive hub. When the signals starts regenerating, it becomes an active hub, and when it is able to identify the path in order to transmit the signal from one system to another system, it becomes an intelligent hub. But the problem over here is, when we are talking about a star network, we need more cabling and hence it is more costly. And all signal transmissions happen through the hub because that is the central host. And if that central hub or that central host is down, in that case, the entire network or the entire systems, if this is down, the entire systems are they stop working. So if we look over here, we have the star topology where we have all the systems, we have the hubs which are, we have this as a hub, and this hub is connected to different stations. So it is not necessary that you will have the star topology in this format only, in the form of a star. It could be in this format where this is a hub, all the 4 points of the hub are connected over here, and each system is connected either in the circular format or it could be connected in this format. So any single cable connects only 2 devices, as we know that the cable has 2 ends, so only 2 devices can be connected by a single cable. Cabling problems affects 2 nodes at most, because if suppose there is a fault in a cable, then only 2 devices will be hampered, rest all of the network will remain the same. It requires more cabling than ring or a bus network, so more fault tolerant. It can be easily moved, isolated or interconnected with other networks. That is, it again has a feature of scalability. We can either add or remove any of the machine at any point of time without affecting the rest of the network. So the advantages of the star network are, the main advantage of the star architecture over the bus is it small access loss, since in case of end users, the star topology, the access loss increases logarithmically with n number, while in case of end user bus, it increases linearly with n. It is a good option for modern networks. It has a very low startup cost. It is easy to manage and offers opportunities for expansion. The most popular topology in use nowadays is the star topology, and it has a wide variety of equipments available. The only disadvantage that the star topology has, that is, since all the information in a star network goes through a central point, stars are easy to troubleshoot. The next topology that we have is a hybrid topology, which is a combination of 2 or more network topologies. So if we look over here, if we look only this part of the topology, so this part is, we have a single bus running and all the stations are connected on the bus. So this is the bus topology that we discussed in the very beginning. But if we connect all these buses to the hub, so this becomes the star topology that we were just discussing about. Because a single topology cannot survive, that is why we have a combination of, we might have a combination of 1 or 2 topologies. So here, this is a combination of a bus topology and the star topology. So when we have multiple topologies connected together, the area coverage becomes. The other type of topology that we have is a star wired ring. Here again, all these are connected in the form of a star, and all these are connected through a hub again. So this is a ring topology in the form of a star topology. So coming to hybrid topology, the advantage is, as if we look over these two, so it is easy to identify that when we are joining two or more topologies together, the complexity in designing these topologies increase. So that is a disadvantage. It is complex in designing, and again also it would be costly to establish the topologies. The advantage of hybrid topology is it is reliable as the error detection. It is reliable as we are able to identify the errors, and the troubleshooting of those errors is easy. It is more effective. It is scalable as the size can be increased easily, and it is flexible as well. The next type of topology is the mesh topology, where we have all the systems that are connected to each other in the network. So if we are talking about this computer, suppose this is C1. Now this C1 is connected to C2, C3, C4, C5, C6. Similarly, the system C2 would be connected to C3, C4, C5, C6, C1 and so on. So a mesh topology is a topology where one node is connected to all other nodes in the network. So it is a point-to-point connection to other nodes or the devices. Here the traffic is carried only between the two devices or the nodes to which it is connected. The mesh topology has n into n minus 2 by 2 connections, which are used to link any of the n devices that are available into the network. The mesh topology, it connects all the devices to each other for redundancy and fault tolerance. It is also used in wide area networks to interconnect the LANs and for a mission critical networks like those used by banks or financial institutions. Now, when that happens, in that case, what happens is, if suppose we take an example of a bank, we have all the servers interconnected with each other using the mesh topology, and those servers can later be connected to in the form of the client server topology or in any other form, star topology or any topology with the systems into a particular city. Implementing the mesh topology is expensive and difficult because we need a lot of wires or the wireless connections, whatever way we are connecting the two devices. The advantages of the mesh topology is each connection can carry its own data load because the two systems are connected with each other. The fault can be diagnosed easily because each system is connected to every other system. It also provides security and privacy because whenever any system wants to transmit the data to another system, it can directly communicate with that system without moving into the network, and hence this system is more secured because the data transmission takes place in a direct format without going to any other place. The disadvantage of mesh topology is the installation and configuration is difficult. Because the installation and configuration is difficult, the cabling cost could be more, and a very heavy wiring or the bulk wiring is required whenever we are working on the mesh topology. So as we have seen that we have multiple topologies that we have studied till now. Those topologies were the bus, tree, star, ring, hybrid and the mesh topology. So each and every topology has a different area coverage and the different format or a different way or arrangement of the nodes. So each and every topology has either its advantage or the disadvantage. So it completely depends upon the user and the way the data is to be transmitted. Again, the security issues, all those things need to be taken care of whenever we are working on or when we are communicating within the system on a particular network. Thank you.